All right, because a lot of you kind of requested in that poll that you just need some more review, this might help a little bit. This is not difficult. This will not take long, and I think this will help you with the quizzes assignment so that you are successfully getting a better idea about exponential growth and decay. So there is a PDF right above this video link. If you need to kind of take notes on your own paper, that's fine as we do this. But I just like to put my official hand out there too. So if you have kind of some paper that your notebook paper that you're writing on and keeping that organized, that would be great. So we've already looked at these exponential growth and decay kind of formulas, and y'all do a great job of plugging those numbers in. Some things I saw is a lot of people are mistaking, like they don't know how to change 30% to a decimal correctly, which would be 0.3, or like 7% would be 0.07, but that would be the rate. And so we did this with your car project. We talked a little bit about exponential growth and decay back for like real world. So I want to kind of talk a little bit about these examples as we go. So for example one, you're going to find the initial value, the growth or decay factor, the growth decay rate, and write the equation to model the following situation. So this will hopefully help a little bit about what we talked about in that Nearpod about the coronavirus. Okay, so a lot of these examples will sound familiar, hopefully, but if you are going to deposit $200 into a bank account, every year that account will increase by 12%. So right now, just so you understand, the initial value, I think you all have and understand, is $200. The growth factor, well, I'm going to skip that for a minute, our growth rate. So this right here is our growth rate. So 12%, aka if I write that as a decimal, would be 0.12. Now, the growth factor here would be 1 plus that rate. And that's what we kind of do in our equation. You'll see that. So the growth factor, whereas in the video you just watched, I think for the Nearpod was like 1.6. Here it is 1.12. So our equation that you would write to describe the situation would be the amount of money. The initial amount would be 200 times our growth factor to the X number of years. And I know that X would stand for years because of this year right there. So our final equation is y equals 200 times the quantity of 1.2 to the X. Okay? Now, what I want you to do is I want you to maybe pause this video, try this one on your own, and then push play again. So push pause for me and actually give it a try. And I'm trusting that you will, right? Imagine me giving you a look in class. But right now, let's take a look. So this time it talks, says find the initial value again, and it's really the same directions. So the population of an apartment building is 4,000 people. Every month the population goes down by 12%. So I tried to stick with the same percent to show you. So our growth rate, so actually this is going to be called, I'm going to cross this out for you. This is actually going to be what we call a decay rate and a decay factor. So our initial value, we started with 4,000 people in the apartment building. The decay rate is 0.12, but because it says every month it goes down, we would do 1 minus 0.12, which if I'm doing my math right here, that would be 0.88, 80, 90, 100, yeah. So therefore, our equation then would be y equals the initial amount of people times 0.88 0.8 to the x power. And x in this problem stands for every month, because every month it's going down by 0.12 or 12%. So what that means is 0.88 is the percentage of people that are staying in the apartment building. That's why we subtract from 1. So 0.88 is called your growth factor. All right, let's go on. There's only 2 more examples. So in these examples, really what I'm wanting you to do is I want you to use the model and the equation and then answer the questions. So once again, what I'd like you to do is I want you to try 3. If you're not looking at the paper, just do 3. But if you can try 3 and 4 on your own and then check with me, that will help you out a lot more than just waiting for me to give you the answer. So I'm going to go ahead and do that now, and then we'll go from there. So the model is y equals 200 times the quantity of 0.80x. So I can tell from this scenario, and we're kind of going to go backwards here, but our growth factor is 0.80. So this would definitely then be decay because it is smaller than 1. And then the growth rate then would be 0.2. So in order to get that 0.80, I have to ask myself, what did I subtract from 1 that's going to give me that? So in this model, whatever we're talking about, it is decaying by 20% or 0.2. Whether it's year or day, we don't know what that means. Okay? All right, and then the last example is talking about the Cincinnati Reds. Boo-hoo, we missed opening day. But they're signing a new player for $8 million, and his salary will go up by 3% each year. So this is definitely growth. So in this situation, our initial value is $8 million. Must be nice. All right, everyone. Our growth factor would be 1 plus. Now our rate is that it's increasing 3%, so that's 0.03. Make sure you move your decimal 2 spots to the left when you're changing it back to a decimal. So 1.03 gives us a growth rate of 1.03. Our equation would be y equals 8 million times the quantity of 1.03 to the x power, where x stands for the number of years. Okay, so now all you need to finish this off is you're going to take out your calculator, as I am now, you just can't see me. And on that handy dandy calculator, we are going to figure out how much the Cincinnati Reds player is getting after 4 years. So we're going to type in 1.03, which is 3%. Do not do 1.3. That'd be 30%. That'd be an insanely amount of money. But 1.03, and you're going to take that to the 4th power. And then once you have that number, you're going to multiply by 8 million. And I got an answer of, hopefully yours matches mine and I did my math right, $9,004,070.48. I'll take that. So once again, $9,004,070.48. All right, I hope this helps a little bit explain the difference between your growth decay factor and then the growth and decay rate. So if there was any issues there, we've cleared that up. So now you're on to your quizzes, and then after that, we'll go back to Unit 7, and you're almost done for the week. Great job, everyone. Have a good day. Bye.